few years now. I've been teaching it for about 4, I've been designing it for about 10. And I always felt like I was in the dark, because nobody else was thinking this way. Nobody else was like doing like similar triangles in 105 or about to start doing in 105. And I began to realize that like, maybe I'm doing it wrong. You know, maybe I'm doing it wrong. And then I saw Washington State just signed off on it. I'm like, oh, okay. Well, I'm at least 80% correct by Washington standards. And they have good apples, so maybe that's worth something. So then I started thinking, okay, how correct? So I got 80% of the same topics. So then I started looking at like the individual pieces of their topic. And one of the biggest things they liked was called proportional reasoning. Being able to apply scalars, S-C-A-L-A-R-S, to a problem. Now, that's a fancy word, but if you think about it, it's what you guys are doing right now. You're scaling triangles. You're making a small one bigger or a bigger one smaller. We just had this discussion, Pam, right? 3/17 versus 17/3. Exactly the same idea. So I checked that off in my mind. Yay! And then a couple topics down was statistical literacy. And I'm like, holy crap. Because the next idea I had for you guys for today was fusing those two things together. So let's get into it. Let's get into it. Okay, it was on earlier, wasn't it? Now it's going to turn itself back on. Please, answer that question.
Sorry, I should have asked this
No,
earlier.
don't be sorry.
So once we figured out, once we did all the math on that,
Yes.
we essentially should be able to figure out the grade and the angle.
Yes! As a matter of fact, you can figure the grade out before you go any further.
Right.
Because you know one of the triangles is 10 20-seconds.
Right.
The other one is 2.
Right.
But it's something 30ths.
Yeah,
But
yeah,
it's still the
great.
same, right, it's still the same grade, isn't it?
Yeah,
Absolutely.
I just wanted to make sure.
Okay, it's got to warm back up again, I apologize. I thought it was on earlier. Maybe I'm completely out of my mind. So I found out a way, and we may have to kill the lights on this one, to kind of fuse the ideas of similar triangles, and I know, it's kind of small. You'll have the PowerPoint linked for you on the schedule page after today's over. But go ahead and read the headline, which most Americans do anyway, and they don't read anything else. Percentage of Americans lacking health coverage falls again. Okay. How many of you have heard a headline like this similar? This is about a year old now, but it's okay because it's still relevant. We've heard, yes. Tell me your name again.
Ashley.
Ashley, I bet you look every day, I apologize.
It's okay.
So you've heard this before. Why is this in the news?
It's anecdotal. Oh my God.
Oh, it's that. Good. Hold that thought for 35 seconds or so. Why is that in the news? Or why was it in the news a year ago, and why is it? It's gotten kind of quiet, only because we're too busy waging war. Please, Christina.
Obamacare.
Yes, with Obamacare, because I believe 2 months after this was the last date you could sign up for Obamacare. I believe, I'm going by memory now, my memory's not so good. But actually brings up something very important, right? It's the quiz you guys turned in last week, which hopefully I'll have a grade for you guys today once I get able to get them in the grade book, was about interpreting percentages over a short period of time. How many of you guys did that quiz with the PowerPoint that had math errors on it, which I didn't even notice till one of you guys did. It was David, you mentioned, or Amber, somebody mentioned. I didn't realize that the person that made the slide had made math errors, which is adorable. But that's anecdotal percentage evidence, as is this. As is this. Okay, percentage of Americans lacking health coverage falls again. Okay, so it is a bit anecdotal because if you go down and actually look at the trends of what's happened, the trend of certain groups is not falling. It might fall in the short run, right? But that's like saying the Mackenzie River Trail is an uphill bike ride. Remember? That's what my wife says. Oh, I hate that ride, those hills. I mean, I rode Crater Lake yesterday. I rode around Crater Lake. Technically speaking, my average grade for the whole trip, because I rode around Crater Lake, my average grade was 0! Because I ended up back where we parked. I didn't go anywhere. If you look at just the average grade, I didn't go anywhere. Anybody ever ridden their bike around Crater Lake? It's friggin' awesome. You should totally do it. I've done it twice now, once on a tandem and yesterday on my own bike, and it's amazing. You climb thousands of feet of elevation as you go up and down and up and down. There are sections that are 12% grade, and there are sections where you're hitting 45 miles an hour downhill, which you want to be careful. I found out yesterday, some of the roads aren't in the best shape. But nonetheless, on average, it averages out to 0, but that ignores the individual pieces. Well, this is the opposite of that. This is ignoring the overall trends and focusing only on these little anecdotal drops, which really are, if you think about it, hiccups in the system. Look, drop, drop. It happened before, yeah? So the news, I blame Ted Turner. Ted Turner gave us CNN back in the 1980s. Because his decision was we need to have news 24/7. It's not good enough to have Brian Jennings on for 1 hour every night. Yeah, it really is good enough to have, anyway. I want to get into a less anecdotal, more statistical way of analyzing this today with you guys. Okay, so I got some data for us to play with. Now, this is going back because I wanted to set the stage for a non-anecdotal attempt to quantify what's going on in the news. And we're going to bring it into the current day as we go. So, this is data pulled from, where did I get this data from? I forget which government bureaucracy I pulled this from.
Health America.
Oh man, it was something like that. It was one of those .gov sites. So I trust their data. That doesn't mean I should. I just do. Because I'm not so much interested in how they got their data as interpreting the data correctly. Now the data might be crap, although I don't think it is. At least I hope it's not. So here are the number of uninsured from 1992 to 2000. Notice it's climbing. Is this in stark contrast to the headline, percentage of Americans lacking health coverage falls again? Is that in stark contrast? Tell me why it's not. Give me one reason why it's not in stark contrast.
Because it's been continually falling. It's
Oh,
not...
according to them, certain groups have been continually falling, but this is continually rising.
Well, I mean, that's what I meant, like the
Oh.
number of people.
Gotcha.
Yeah.
So you have to think about this. This is number of uninsured Americans. How has the population of America changed over that same time? Right, the population has been going up over the same time period. Roughly, the human race doubles every 40 years.
It should be percentages.
Correct. Although the raw data I was able to get wasn't in percentage form, we can convert the percentage form momentarily. When I say momentarily, I probably mean Wednesday. We'll get to that. Probably on Wednesday together when we regroup. So we're not looking at an apples-apples comparison yet. We're looking strictly at the number of uninsured. But once we have the number of uninsured, we can go back in, figure out how many Americans are here right now. FYI, how many Americans are in the United States right now?
A lot.
So just FYI, again, a wonderful, wonderful way to use Google. Whoa, what is that? I don't know what that is. Number of Americans. There we go. Right now, this is from Wikipedia, but I guarantee the source is from the Census Bureau. About 309 million Americans. I often use 310 as a round number, but 309, there you go. So again, if you got a question, ask Google. Remember the website ask.com?
Yeah.
Google has like swallowed that up. You can ask Google questions now. I mean, it's a wonderful thing. Anyway, back to this. All right. So hopefully, I want to analyze these statistically and not anecdotally. So these numbers are a little bit large, 35 million, 38 million, 39 million. I'm going to knock this down to this to play with, if it's okay with you guys. Now you just got to know that when you see those, you know that there are millions over here, and that's years after 1990 over there. And this is going to serve us well. We're going to analyze Mount Bachelor. Maybe not today. I'm thinking we're going to get to Mount Bachelor on Wednesday. Ticket prices for a lift ticket at Mount Bachelor. See how that's changed over the time. We're also going to analyze the measurement of our forearm to our fingers. It doesn't matter what you're measuring and what unit you use, as long as you're consistent with what you're doing. What I like about this, though, this is my Math 243 class made up a name for this. They call it a T-table, which I think is what you guys called this kind of thing in like an algebra class, like an X. Elementary school. Dude, I like that even better. It's already in your mind. You've got an X column and a Y column. But the only difference is now the X and the Y have titles. This is years after 1990, and this is that number of uninsured in millions. And we're going to have this, like I said, we're going to have this for you guys available, downloadable from the website, so you can take a look at this later if you need more time. I'm going to jump to the next page. Still got the data up there, though. Still got the data, a data table, or a T-table, or an XY table, or whatever else you want to call it. They have a different name for it they used to talk about that. Even going like that, it's like a T. So that's your data. But to help me visualize the data, that's a fun noise. Sounds like R2D2.
It does.
I make what's called a scatter plot. A scatter plot. How many of you have seen one of these before? Somewhere. Okay, roughly a third of you, maybe a quarter to a third of you. That's not many. Good, I assume you never have. I'm going to assume you never have. What are we looking at here compared to that? Because if I look at the T-table, I see 10 numbers. But if I look in the scatter plot, I see 5 points. Am I ignoring half of my data? Am I ignoring half my data? Please.
You're just finding the trends.
Not Andrea. Wait. Oh, damn it. Actually, that was my next guess. That was my next guess. Go ahead. I'm ignoring. Say it again.
The trends. Now you're looking at the trends.
I'm trying. Good. Okay, good. Again, you're 35 seconds ahead of me. I love that, Ashley.
Sorry.
I am trying to find the trend. No, I want to find the trend. There is definitely a trend here that makes me interested. But I'm worried about, am I trending on lost data, Megan? Help me.
Oh, well, for each point, because you have your X and your Y column, they correspond with the independent and dependent variables.
Beautiful. So what I've done is I've taken a, if you will, a one-dimensional table, up to down, and I've put an X and a Y to make it two-dimensional, which means each of the points now corresponds to one of the pairs of numbers up top. So this guy right here, it's a point. It's got coordinates, right? 2, 35. Ah, good. And we look right up there. Yes, actually, 235. So that point represents the millions of uninsured in 1992. Excellent. Excellent. This point right here, 4 years since 1990. That must be 1994.
26.
Absolutely. Goes with the 38 million that's up there. Fair enough so far? 6, 1996. Goes with 39 million. I see it up there, and so forth and so on. Now, why do I like doing this? Why do I like doing it? Tell me your name again.
Anya.
Anya, go!
It's visual.
Oh, I like visual. Do you guys like visual? What would you rather look at, the top or the bottom? And there's no right answer to this question. I would too. And why in particular, Anya, do I like that visuality, if that's even a word?
Because you can interpret the data in a better way.
I can see. Oh, Amy, hold that thought. I'll let that Anya. Go ahead, Amy.
Linear for our eyes, the way our eyes work.
Oh, good.
Left to right.
Oh,
right.
so do you like the table better then?
Yeah,
Oh, you do? Okay.
I do.
Totally fine. Hey, I got no problem with that. We do read left to right, up to down. It's trickier here because you have to kind of interrupt that by going left to right and up to down kind of at the same time. Good. So that might be a negative for a scatter plot versus the table. I got no problem with that. Please,
You don't
Kristen.
have to look at the numbers, you can see that the trend is going up.
Back to Ashley's trend again. I'm hearing this trend. Emily, is that right? Emily, go ahead.
It kind of makes it relatable
To what? I like that word.
to just real life, how you would look at something.
Okay, so did you hear this? I find this very interesting. We've got two very similar answers. Make it relatable to how you would look at something, except both of you are voting for different representation. I love that.
Well, if you drew a line on that one,
Well, what line would you draw on that?
I don't know.
So now I want to come
Add a
back.
line, like
I
a
want to
line.
come back to Ashley's question, and I may have to. I want to clear the board here a second. I love that if you drew a line on that one, right to line.
Makes it easier.
Okay, hang on one second. Let me clear the board, and I may have to close the PowerPoint out and pull the graph down. Let me see if I can do that real quick. Yeah, I can. Let's do this, and then reopen it to here. Almost. A little lower. Love it! We'll make this work. Make this work yet. Okay, so I've heard now 3 very fun